Hey everybody. So I want to welcome you back again. So in this video, we're going to be talking about science standards. So some of you might already be familiar with the Florida Sunshine State Standards, but we're actually going to be talking about more than just those standards. So let's go ahead and get started. And talking about different types of science standards, like I said, let's start with the Florida State Standards. We also have something called the Next Generation Science Standards. And though Florida hasn't adopted it or hasn't adopted them, this is something that you're going to be interested in knowing about and possibly implementing in your classroom in some way. So what we do is we go to the CPALM's website. And once it comes up, we're going to be looking at the different standards. So since we're interested in science, I'm going to be going down to science, and we have it broken up by the different grade levels. So let's just pick on grade 4. So life science, physical science, earth, space, nature, science. So you can see how the categories are broken up, L, P, E, N. So let's go to physical science. So you see here on the left, you have these different big ideas. So big idea 10, big idea 11, energy, transfer and transformation. And so I want to learn more about forms of energy. Here you see you have 4 different standards as they relate to energy. Well, if I want to read more about the forms of energy, I'm going to open up this link in the new tab. So this is relating back to Big Idea 10 forms of energy, because these big ideas go across different grade levels. And so what we're looking at, we know energy is involved in all physical processes, and it's a unifying concept in many areas of science. And so what we're doing here, we're looking at specific aspects of forms of energy. So observe and describe some basic forms of energy, including light, heat, sound, electrical, and the energy of motion. Now they also give you different levels. So this is a level 2, which is basic application skills. Level 3, strategic thinking. If I go down here and let's say click on energy transfer and transformations, you can see, oh, well, this is a level 1 recall. Now, this is saying, I recognize that heat flows from a hot object to a cold object, and the heat flow may cause materials to change temperature. Heat is probably one of the most difficult topics in science to understand. Part of the reason that is because if you talk to a chemist, heat is a type of energy. If you talk to a physicist, heat is the transfer of energy from one object to another. So a chemist uses heat as almost like a noun, like a physicist thinks of heat as a verb, it's an action. We use thermal energy. So if I click on this particular standard, you see here SC4, so science 4, P for physical science 10.1. Again, you have that same information. Here's your big idea again, level 2, grade 4. And they also give you a lot of different resources. So if there's courses, teaching ideas, tutorials, lesson plans, assessments, collections. So there's a lot of different information for you within these state standards. So you want to make sure, pay attention to them, look at them, and you'll see that information, is going to be very helpful for you. We also have motion of objects, properties of matter, changes in matter, and that's how we can kind of use the Florida State Standards. Because one thing with standards, whether you love them, whether you hate them, they are a part of an educator's life. So if a supervisor walks in, they're probably going to ask you, what standards are you addressing today? Or they could also ask you, how is what you're doing addresses the standard that you say that it's addressing? So these are skills that you're going to have to be able to develop as a teacher to show what it is that you're doing and how it addresses the standards. Now, the other standard I want to talk about, the other set of standards is what I call the next generation science standards. Now, this was, you see the hashtag for states by states, and this was developed by multiple states across the United States, and multiple states actually also implement them as well, not necessarily the ones that created them. However, unfortunately, Florida does not accept, is not using the NGSS, but I still feel it's incredibly important for you to know what they are. So let's go stick with 4th grade. So I'm going to go search for 4th grade. And I go down here and I see, oh, well, here's energy. Energy again, energy. And so we have wave in our applications. So let's pick on the first one. Now, what's interesting, I'm going to make it a little bit smaller. Use evidence to construct an explanation relating the speed of an object to the energy of that object. Well, if I go back to the energies here, investigate and describe that energy has the ability to cause motion or create change. It's kind of similar, but kind of different. Now, before I get too much more into this, let's talk a little bit more about the next generation science standards, kind of where they come from, a little bit about the history. So, the NGSS has its root in this book. It's called A Framework for K through 12 Science Education. This came out in July of 2011. Now, a group of educators, some of them are individuals like myself or university professors, others are supervisors, maybe science specialists or science classroom teachers from all of these states in blue, so you can see where they're all in here, they came together and they use this as a starting point to come up with the next generation science standards. So these are created for the states, by the states. Now, it's not just the standards, but there's assessments, there's curricular instruction, teacher development activities to go along with it. Some of the states, so for example, Georgia is one state that helped develop the standards, but it decided it didn't want to actually adopt them. As you know, education can be very political. So Georgia has a Georgia grown, Georgia owned type model. So since they were not strictly developed by Georgia, they weren't going to adopt them in their state, which I think is kind of ironic because, if I'm needing a piece of equipment for life support and I live in Florida, I don't care where that piece of equipment was made, just that it does its job. Now, the next generation science standards were one of the failures for Common Core was that they never really marketed the standards properly. They brought them out, and you've probably seen a lot of the videos where it's like, oh, I've done this 30 seconds the traditional way. It takes me 5 minutes to use Common Core. Where is this? Well, where's the logic in this? Well, the problem is that there was never really the explanations in the marketing as to why we're doing it. And so there was faced with a lot of pushback and a lot of adversity to it. Well, one way to think about this is, a lot of people have difficulties with math and don't like math. So maybe the way that we were doing it wasn't necessarily the best way. So let's come on back to the science standards now. And the next generation standard had some basic principles that they worked off of. Key above everything is that children are born investigators. They ask questions. In elementary school, that's what I said before, elementary is the best time to teach because you're naturally inquisitive. But they also realize that understanding builds over time, that you learn one thing and then you learn something different. Now you learn something different. No, understanding of that concept takes time. And so we build upon it. It's like a spiral effect. Science and engineering, it's not just the knowledge, but it's also the practice. It's how do you do it? And one thing that is critical is the students' interests and experiences. You have to connect them to the standards. So what the NGSS does, it focuses on these major core ideas and these practices, which we're going to show you some examples of. And finally, and we're going to spend some more time talking about this later, is promoting equity within the classroom. So the practices are the processes, the building of the understanding. The core ideas and the cross-cutting concepts, these cross-cutting concepts are where, if I'm talking about this one thing, well, science is in a silo. How does this relate to other aspects or other ideas? And so we have those different cross-cutting concepts, and then finally, we have our core ideas. Now, if you look at it, here's your NGSS box. So let's actually go back to this particular standard, and I'm going to zoom back in again. Here's your standard. Use the evidence to construct an explanation relating the speed of an object to the energy of that object. Here's what's called an assessment boundary. The assessment does not include quantitative measures of change in the speed of an object or any piece of quantitative definition of energy. So they're telling us, like, look, we don't care about the numbers in 4th grade. Qualitatively, just tell us what's happening. So it's like, this is the limit. Don't go beyond this in 4th grade. Look, here's your practices. Constructing explanations, use evidence of measurements. Disciplinary core ideas. The faster a given object is moving, the more energy it possesses. Cross-cutting concepts. Energy can't be transferred in various ways and in between objects. So you see how here I start moving down. Where does this go across grade levels? Well, it's a cycle. So when we're looking at energy, here's the middle school science 3. So what's important for you as an educator in elementary school is to see those alignments, see those vertical alignments. What do I need to do in elementary school to get my students ready for middle school? Because what are they going to be doing in middle school? What do they have to do in middle school? And what's my role? What's my job to get them ready to be able to do that. So this is where it's also important to look at those vertical alignments. And now we also have the Common Core, ELA, and literacy connections. So refer to details and examples in a text when explaining what the text says explicitly. Well, if I look back to the Florida standards, investigate and describe that energy has the ability. Here we're saying use evidence to construct an explanation. So the wording might be slightly different, but it does take on a different meaning. And there is that you have to use the evidence and you need to construct that explanation. This is what you need to do. So you can see here, here's our connections, here's our cross-cutting concepts, core ideas, processes. And so we kind of get a little bit of an idea as to how the NGSS is typically going to be laid out if you're going ahead and you're looking at things. Now, what I'm going to do is I'm going to spend a little bit of time in the next part of the lesson focusing on one cross-cutting concept in particular. You can see there's patterns, cause and effect, scale, proportion, system models, energy and matter, structure and function, stability and change. Now, you probably have already figured out, well, scale, proportion, and quantities in red, so that's the one we're going to focus on. You'd be right. But the reason that I'm choosing this one is because scale, proportion, and quantities is a very difficult idea, not just for students, but for adults to figure out. I mean, first we have to figure out how do we measure these things, and we need to figure out, just be able to wrap our mind and comprehend what's happening. Things happen at different rates. How do we measure them? How do we look at something happening quickly? How do we look at something happening slowly? How do we look at things that are acting on a larger scale? How do they affect things happen on a small scale? So if you think about it, when we talk about scales, it's not the scale that I use to measure my weight. I mean, that's a device that I use that is a type of scale, but like temperature scales, all these different things are scales that we encounter in a science class. But we want to kind of categorize these things into a broader area. There's going to be things that are too large or too slow for us to ever observe. So we need to think about, how do we look at these things? So anything that we can directly observe, or we're going to call a microscopic type of scale. So if I can see it, touch it, feel it, manipulate it, if I can observe it. But not everything that I see that's out there is I can observe like this. So there are, for example, some things that are too small to observe. There's things that are going to be too fast. So what we're going to do in the next set of videos and the next set of activities is we're going to kind of take a look and really dissect some of those scales. What are those things that are too small, that are too large? And hopefully we're going to see, like, I have problems with some of these too. So as you're doing some of the next activities, don't feel bad if it's like, whoa, I was completely off base. Trust me, I'm right there with you. So stop here, go through, answer some of the questions, and pick up on the survey. And I look forward to chatting with you soon. Talk to you later. Bye-bye.